So today we will be making a problem on classification. We will be using a simple problem of a classification using CNN. CNN stands for Convolution Neural Network. So for this, the data set that we are using is of cats and dogs. Here you can see on the screen I have a zip file. This file will be available for you on the Google Drive. Here you can see there are two folders, train and validation. The train folder, it is having two folders, subfolders, cats and dogs. These act as a labels. These are the images of cats. We'll open it later. So let's begin our program. We'll be using Google Colab and we'll be making the program on TensorFlow. So here I'll come here, more, Google Colab. Okay, let's start making our program from the scratch. So I'll put the heading CNN classification using CNN. Classification of images of cats and dogs using CNN, which is Convolution Neural Network. I'll make it in bold. Okay, let's proceed further. See, now here the first job is we have to access our file. In my case, I have kept this file in the Google Drive and it is in zip format. So I need to unzip it. Before that, first thing what I need to do is to mount the Google Drive. So I'll click here on files. I should get an option here. Yeah, okay. Here, this option, mount drive, connect to Google Drive. And I'll execute this cell. Give the permission to connect to Google Drive. Okay, with this, mounting of the drive is complete. Now we can access the files from my Google Drive. See, also I'll change the runtime. I'll change it to GPU. Okay. Due to limits. Okay, I have used it, so I'll not be able to connect it. We will do it later. Connect without GPU. Now, first I need to unzip the files. So I'll use the command $unzip. And now I need to give the address of that file. For that, I'll come here, this location. I'll go into drive, my drive. Here I'll select the file where I'm storing it, AIML. This is where I have stored my CNN classification, cats and dogs. I'll just copy the path from here and paste it and execute it. Unzip is complete. With this, unzip is complete. Okay. Now let's move ahead. First we will import TensorFlow as TF. Now see, these files, this is an unstructured data, these are the images, right? We need to convert it into a format that can be used by CNN. Basically we have to convert it into numbers, and it is converted into numbers on the basis of pixels. Pixels are nothing but intensity, right? So for this, this is a part of pre-processing. We need to convert the image into numerical form to be used by the CNN. For this we will use the pre-processing feature of the TensorFlow. In that we have a thing called image data generator. For this we will use image data generator of TensorFlow. See, if you need to get any information about it, you can use the Keras documentation. I'll open Google, tf.keras pre-processing, image pre-processing. See, here you can explore it. tf dot image. Okay, I'll directly open image data generator, tf dot keras image data generator. So here I have this this is the syntax, the line of code. I can directly copy it, but right now I will be typing each and everything, okay? So, just for better learning. But we can always refer this documentation, there is no issues with that. tf.keras dot pre-processing dot image dot image data generator. Okay, I'll have to make an object for it. So see, we have two things, right? Test, train and test. So first I will make an object as train generator. So train underscore generator. This is the object for this function. Now I will resize it. I will rescale all the images. One by 255. This is because we are having pixels from value from 0 to 255, right? So for that we just want the value from 0 to 1, so we are rescaling it. Same we will do for test also. Test generator equals to tf dot keras dot pre-processing, sorry, okay, dot image data generator, rescale it to 1/255. We are done here. We'll execute the cell, no issues, no errors. Okay, so now what we have to do, we have to pass our images through this object to convert it, right? So we'll store that data into one variable. So test image data is the variable where my image data will be stored in numerical form. For this we will use flow from directory. Okay, so train underscore generator dot flow from directory. And now we have to give the file name, file path. My file path will be cats and dogs slash train. We can check it here also. I will just show you. See, cats and dogs slash train. Cats and underscore dogs slash train. Then we have to give the batch size. I'll just give it 32. Class mode, which is binary, because we have binary classification, either it is cats or dogs. Okay, and target underscore size equals to 64. This we are giving so as to ensure that all the images that we are generated, they are of same size. Okay, sorry, I made a small mistake here. Okay, done. Same thing we have to do for train also. Train image data. This is the variable where all my training image will be stored, means data of the training image in the form of numerical values will be stored, right? So train underscore generator dot flow from directory okay, cats and dogs slash validation. This I checked it from here, cats and dogs slash validation. Same batch underscore size is 32. Class mode is binary. And target size is 64, 64. Okay, so see, it has been executed. It found 2000 images belonging to two classes and 1000 images belonging to two classes. This is for training and this is for validation. Okay, now we will start to make the model, architecture of the model. So our model is going to have a CNN layer and then it will have an ANN layer. Architecture of the model. Okay, so first we will make a model object. Model equals to tf dot keras dot layers, sorry, tf dot keras dot models dot sequential. Okay, now we have to add the convolution layer. Okay, let's begin with our first convolution layer. First convolution layer. So we will do model dot add tf dot keras dot layers dot conv 2d. We can always check the documentation. tf dot keras conv 2d. See here, these are the features that we can give inside it. So we have to give filters, kernel size, activation, and padding. We also need to give the input shape because this is the first layer. That input shape will be dependent upon the size of our object, size of our data. This is the train image data. So on the basis of that, our target size is 64, right? 64 by 64 by, and there will be 3 also, since it is RGB channel are there, since we are using color images. So first we have to give just a second. Yeah, filters, number of filters. Filters equals to, I'll just give it 32 randomly. Next I have to give kernel size. This I'm getting it from here. Kernel size. Kernel size is I'll make it a 3 by 3. After that I have to give input shape. Input shape we have to give only on the first layer. Same holds true for ANN also. There also only for the first layer we have to give the input layer because that is where we are feeding the data. So the input shape will be the size of this images, test image data. So to make it dynamic, what we will do, test image data dot input underscore shape. We can also check it what value this is out, this will output. See, test image data dot input underscore shape. There seems to be some error. No, put input underscore shape. Test image data. Sorry, this is not input shape, no? It will be image shape, right? I made a mistake here. Okay, we have it here. Sorry, I executed it by mistake, but it's okay, that will be fine. So this is the conv 2D. Input shape we have to add. We have to add 2 more things here. Okay. We will have activation as ReLU. See, activation function is not required, but generally we put it to ensure that all the values are positive. Like if by mistake some value comes negative, it will convert it to a positive value so as to avoid any exception. because generally what happens, training of CNN usually takes many hours. Now if at the if after 90% some exception is encountered, all our hard work will be wasted, all our time will be wasted, resource will be wasted. To avoid that, we usually use activation as ReLU to ensure all the values are positive. Okay. Now here we will add padding as seam. Next we will add max pooling layer. Model.add tf.keras.layers max pooling 2D, and here we have to pass the parameters pool size. Pool size equals to 2, 2. Here we are done with our first convolution layer. Similarly, we will make the second convolution layer also. Model.add tf.keras.layers.conv2d filters equals to this time I'll use 16 filters on this layer. Kernel size will be same, 3 by 3. Input, this time I do not need to give the input shape, I just need to give the activation. Activation will be ReLU and padding is same. Again we will add the max pooling. Model.add tf.keras.layers max pooling 2D. Pool underscore size is equals to 2, 2. We will add one more convolution layer, third convolution layer. Model, just a minute, model.add tf.keras.layers.conv2d. This time filters will be 8. Kernel size is 3, 3. Activation is equals to ReLU and padding is same. Again max pooling. Model.add tf.keras.layers.max pooling 2D. Pool underscore size is equals to 2, 2. Okay. With this we will conclude our convolution layer. Now we have to flatten it. For flatten there is a simple command, model.add tf.keras.layers.flatten. Simple. Now we have to make the ANN. Artificial fully ANN, also known as FC network. That's fully connected. Okay. So for this we will go model.add tf.keras.layers.dense. Here we have to give units. Right now, see, this units will be equal to the units that we have to give. This should be equal to the output of flatten layer. This we'll see how to put it. For now, randomly I'll give it some value 512, 515, any random value. Activation will be ReLU. That's all. We'll add one dropout layer to overcome to avoid overfitting. Model.add tf.keras.layers.dropout. tf.keras dropout. See, if you check here, we have to give the dropout rate. I'll give the rate as 20%, 0.2. We'll add the second layer. Model.add tf.keras.layers.dense units equals to 256, activation equals to ReLU, and then the third layer. Here I'll directly give the output layer. You can add any number of layers you want. Here's dot dense units equal to 1. Since I have a binary classification, and I'll be using the activation function as sigmoid. There is one interesting thing here. I'll tell it is in comments. Like if you are using units as 2, then you will have to use the activation function as softmax. I'll just put it in comment. So basically we can use this form, this line also, units equal to 2 comma activation equal to softmax. Okay, we'll execute this cell. For now, I will change the runtime to CPU only. Mass pooling, I have made a spelling mistake. max pooling. Okay. P should be capital. There seems to be some error. Let me check it. 28 model dot. Why I am getting this error? Max pooling 2D. I think it is because of this D. So D should have been capital. Okay. Layers is not defined because of this comma here. Okay, I got this error also. Okay, I'm done with this. Now see, I have to decide what is the input shape here for my ANN, right? After the flatten layer, this part. So to get that, I'll just use model.summary. Okay, see here I'll have flatten. Flatten is having 512, right? So directly this 512 I'll give here. See, by default right now I have given 512 here. This was just just by chance I gave it. Any random number, generally I would have given here any random number. Right now by coincidence, whatever this output flatten is giving, it is 512 only. So that's why I'll use 512 here directly. Okay, so now I need to compile the model. I will use the optimizer as Adam. Loss function I'll use as binary cross entropy. For multi-class classification, I would have used sparse cross entropy or categorical cross entropy. And metrics I have to use as accuracy. Okay, compilation of the model is done. Just for the sake of it, might create an error. Okay, and with now I have to fit it. So model dot fit. Which data I have to fit? Train image data. I'll have to give some validation data. This will be my test image data. Epochs, I'll keep it to 50 for now for simplicity. Steps per epoch. This I will give it as length of train image data dot file names divided by train image data dot batch size, and validation steps same as length of test image data divided by dot file names divided by test image data dot batch size, and we'll execute it. Test image data. Okay, I should be capital here somewhere. Test image. Okay, so we see here our this has started, training has started. Once this training is completed, we can check the summary. For now, we will conclude our program here only. This will take some time, and after it is completed, we can will see the results.